Hi everybody, here in this video I am going to tell about the features of modern periodic table. The previous scientists Dobereiner, Newland, Mendeleev, Lothair considered atomic weight as a characteristic property for element. In 1913, scientist Mosley proved that instead of atomic weight, atomic number is to be considered as a characteristic property of an element. We know that when cathode rays strike over the metallic object, X-rays we have formed. Square root of frequency of X-ray is directly proportional to the number of positive charges present in the metallic object. So this observation forced Mosley to conclude that atomic number is the characteristic property of element and atomic weight, atomic mass is not a characteristic property of an element. In modern periodic table, elements are arranged as per the increasing, that is ascending order of atomic number, and elements with identical properties, elements with identical general outer shell electronic configuration was placed in a same vertical column. So let me tell you the features of modern periodic table. Term group is nothing but the vertical columns in periodic table are known as the group. Modern periodic table consists of 18 groups, group number 1, 2, 3, 4 up to the group number 18, and horizontal rows in periodic table are known as the periods. Here there are the total 7 periods. These are the elements belonging to the first period, this is the second period, this is the third one, like that 4 to 7 periods are there. At the bottom some elements are shown. These elements are the cerium to lutetium, these are the members of 6th period, and thorium to the lawrencium, these are the members of the 7th period. Okay, so let's see, I am telling you the features in this lecture. To the scientific world, till today 118 elements are known, and these elements are blocked, categorized into the 4 blocks S, P, D and F. S block elements are the elements in atoms of which last electron enters into the S subshell of last shell are known as the S block elements. Elements belonging to the first group and second group are known as the S block elements. Elements in atoms of which last electron enters into the P subshell of the last shell are known as the P block elements. Elements belonging to the group number 13 to group number 18, these are the P block elements. Elements in atoms of which last electron enters into the D subshell of second last shell, that is the penultimate shell, are known as the D block elements. Here those which are present in between group number 3 to group number 12 are the D block elements. Exception is of the few elements that I will tell you. What are the F block elements? Elements in atoms of which last electron enters into the F subshell of the pre-penultimate shell, means third last shell, are known as the F block elements. Here we have the elements cerium to the lutetium and thorium to lawrencium. These are the F block elements. So these are placed separately. Here we have S block elements, here P block elements, here D block element, at the bottom F block elements are there. S block elements, as I told, first group and second group are the S block elements. First group elements having a general outer shell electronic configuration NS1. N stands for the last shell. For example, hydrogen belongs to the first period, its last shell is the first shell is the last shell. Lithium belongs to the second period, the second shell is the last shell for the lithium, and so on. Say for example, potassium belongs to fourth period, means fourth shell is the last shell for the potassium. So what is the general outer shell electronic configuration of first group elements? It's a NS1. That's why first group element, it's a last shell electronic configuration for hydrogen is 1s1, for lithium it is 2s1, then here 3s1, 4s1, 5s1, 6s1 for cesium, 7s1 for the francium. First group elements are also known as the alkali metals. Second group elements from beryllium to radium. Okay, now if we add 1, lithium atomic number 3, if we add 1, it becomes 4 atomic number of beryllium. Sodium atomic number 11, if we add 1, it becomes atomic number of the magnesium, that's the 12. So beryllium to radium, these are the these are the elements belonging to the second group. These are the alkaline earth metals, and their general outer shell electronic configuration is NS2. N means what I told, N means the last shell. So beryllium belongs to second period, means last shell of the beryllium atom is the second shell. So its outer shell electronic configuration is 2s2, here magnesium 3s2, here 4s2, and so on. Okay. First group elements having one electron in their valence shell, they loses one valence electron, that's why their valency is 1. Second group elements have a 2 electrons in their valence shell, they loses 2 valence electron, that's why their valency is 2. The word alkali is derived from the Arabic word alquiz, which means in old days the term alquiz was used for the decays of the plants, and it was found that decays of plants when mixed with the water, they produces the basic solution. So later on the term alquiz was used for the substances which are basic in nature, and the oxides and hydroxides of the first and second group elements are the basic, means alkaline in nature. These are the highly electropositive metals. Okay, electro means electron, positive means rich. These elements can lose electron very easily. They are highly electropositive, highly reactive metals. Now p block elements, just have a look. P block elements, first we have a group 13 elements. It starts with the boron. Boron, aluminium, gallium, indium, thallium, and neonium. These elements are there. Then their general outer shell electronic configuration is ns2np1. Last shell consists of 3 electron, ns2np1. So easily you can make here, for example, 2s2 2p1, 3s2 3p1, like that. To which period the element belong, we should know. Group 14 elements are the carbon family elements. General outer shell electronic configuration is ns2np2. Means for carbon it's a 2s2 2p2, silicon 3s2 3p2, and so on. See, in last series of these elements, here francium, radium, here that neonium, flavorium, these are the radioactive elements, isn't it? And they are very their occurrence is also a rare one. Group 15 elements are the nitrogen family elements, which are also known as the nicogens. Why the word nicogen is used? Nicogens, the word is used because that word means the suffocating. Compounds of nitrogen and phosphorus are the suffocating in nature, okay na, causing breathlessness, and that's why the name to this group elements is given as a nicogens, means the compounds of which these substances are suffocating, causes breathlessness. Nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. These elements are there in the 15th group. 16th group is the oxygen family elements, chalcogens. Chalcogens means ore forming elements. Iron exists in the form of hematite over Fe2O3. Zinc exists in the form of ZnO. Means many elements exist in nature in the form of their oxides, isn't it? And some of them are existed in the form of their sulfide. For example, FeS2. Iron exists in the form of FeS2, iron pyrite. Zinc exists in the form of ZnS, zinc blend. Copper exists in the form of copper pyrite, CuFeS2. So these are the ore forming elements. Ore forming means chalcogens belongs to 16th group. 17th group elements, okay, 17th group elements, fluorine family elements. Halogens means salt forming elements. We are familiar with the salt NaCl. Besides NaCl, KCl, then NaBr, okay na, CaCl2, like that. Salts are get formed by the fluorine, chlorine, bromine, iodine, astatine. Tennessine is the radioactive one. So these are the halogens. General outer shell electronic configuration of carbon family elements, I told ns2np2. Nitrogen family elements ns2np3. Oxygen family elements ns2np4. Here fluorine family elements ns2np5. Now the last group number 18 elements are also p block elements, because last general outer shell electronic configuration is ns2np6. Their group 18 elements, their last electron is entering into the p subshell. That's why these are the p block elements. Exception is of the helium, because it have only 2 electron in the valence shell. Its electronic configuration is 1s2, but remaining here 2s2 2p6, neon 3s2 3p6, argon 4s2 4p6, krypton, and so on. Okay, so these are the p block elements. P subshell consists of the 6 electrons. If the p subshell consists of 1 electron, it's a 13th group element. P subshell if consists of 2 electrons, 14th group element, and so on. Then d block elements. Here it starts from the scandium atomic number 21. There are the 4 series of the d block elements. We call them as a 3d, 4d, 5d, and 6d series. Okay, that's 6d, 3d, 4d, 5d, and 6d. 6d includes the radioactive elements. So when we are studying the transition elements or d block elements, mainly will deal with the 3D, 4D and 5D series elements. But as per the theoretical definition, last electron enters into the D subshell for the 6D series element. That's why these are also D block elements. Okay students. Now the next the D block first series starts from scandium atomic number 21. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This is 3D, the electronic configuration. Perhaps you know 3D1, 3D2, 3D3 up to the 3D10. Okay, chromium, copper, that's the exceptional one. But this is not part. The currently I want to tell you as maximum as possible the features of periodic table. So D block elements, there are the 4 series of D block elements. That is first transition series, that is 3D series, starts with scandium, ends with zinc. Second transition series, 4D series, starts with yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver and cadmium. So these are the elements belong to the 4D series or second transition series. Then lanthanum and hafnium to mercury, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, then gold and mercury. These elements belong to the which series? 5D series. And lastly 6D series or 4th transition series is which one? Actinium, and here ruthenium, dubnium, seaborgium, borium, hessium, micnerium, then damstadium, rontgenium and copernicium. These elements belong to the 6D series or the 4th transition series. Okay. Now the last, this is about the D block elements, last shell electron. Here we are for the 3D, chromium, copper shows the exceptional electronic configuration, and many of them shows the some slight deviation in the electronic configuration, but this is not a core part of current lecture. F block elements starts with here cerium atomic number 58. Okay now, elements after lanthanum are the lanthanides. So cerium, praseodymium, neodymium, here these are cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium and lutetium. Atomic number 58 to 71. For these elements, last electron entering into the 4F subshell. That's why these are the 4F series elements or first inner transition series elements or F block elements. Secondly, elements after actinium 89. So atomic number 90 to atomic number 103. Which elements are there? Thorium, proactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium and lawrencium. These elements belong to the 5F series, and these elements are also known as the elements of second inner transition series. Last electron is entering into the 5F subshell. So this is about the what I told about the SPDF total element, SPDF block elements, group number, how many group, how many period, 18 group and 7 periods are there, and names of elements I told. Okay. So we'll see about the 2-3 things. Okay. First one about the position of hydrogen. Position of element in periodic table is fixed as by the 2 things. First thing is its electronic configuration, and second one the properties. Hydrogen shows resemblance in electronic configuration with the first group elements. Okay na, NS1, all these have a general outer shell electronic configuration. Hydrogen shows 1s1. That's why hydrogen should be here. And secondly, hydrogen didn't show the properties of these alkali metals. Many properties are different one. I am not saying all properties are different, but many properties are different. For example, these are the highly electropositive metals. So hydrogen is not a metal. These are silvery white colored substances. Hydrogen is not a silvery white colored substance. The first group elements are the solids. Hydrogen is not a solid one. So that's why hydrogen is to be studied separately. Okay. So one may take the hydrogen somewhere else. It is neither member of any group and any period. But if we want to consider the electronic configuration, so we should keep here. Okay, hydrogen resembles with the electronic configuration, but many properties of hydrogen and these alkali metals are different one. While learning the S block elements, hydrogen is not studied, it is to be studied separately. Then second thing, the lanthanum. Lanthanum, is it a D block element or is it a F block element? Lanthanum is a D block element. Its outer shell electronic configuration is 6s2 5d1 4f0. Last electron is entering into the 5d, and that's why it's a D block element, isn't it? Even though it is D block elements, its properties resembles with these lanthanides. Okay. but here we should take it as a d block element. Same is for the actinium. Last electron is entering into the 6d series, but it shows the resemblance with this thorium, proactinium, like that elements, isn't it? That's why it should be it is also d block element. So literally what are lanthanides? Elements after lanthanum. Series of 14 elements after lanthanum are the lanthanides. Series of 14 elements after actinium, these are the actinides. Okay, and many interesting things are there. Elements, names of few elements are derived from the names of places. For example, from the Russia, capital of Russia is Moscow. So their scientists gave name to the one element as a Moscovium. Dubna is placed in Russia. Name to the one element is given as a dubnium, symbol Db, isn't it? Rhodanium. The scientist Carl Claus discovered one element, and his motherland was Rhodania in Russia. So they gave the name to the element as a Rhodanium. Then American scientists said the name to this element is to be Americium, Am. Okay, Californium, CF. University of California, scientists from University of California, they gave name to the element as a Californium here. Berkeley is one city in America, so the name to the one element is given as a Berkeley. So name Scandinavian countries are there. Northern Europe, it includes the Norway, Denmark, Sweden. So these countries are the Scandinavian countries. So scientists, they gave name to the one element as a scandium. The name scandium is derived from the Scandinavian countries. Like that, magnesium and manganese, these are given because one district is there. Magnesia is a district in a Greece, and the name to the elements are given magnesium and manganese based on that magnesia. Gaul, Latin name of France is a Gaul, and that's why they gave name as a gallium. Okay now, and like that, some elements are there. In Sweden, one village is there, Ytterby, and in that Ytterby village, ores of few elements are get discovered. For example, yttrium, where the yttrium is here, yttrium atomic number 39, terbium here, terbium. We can determine atomic number easily because first and last I gave you yttrium, terbium, ytterbium, and erbium. Ores of these elements occur firstly in that village Ytterby of that Sweden, and that's why name to these elements are given as a yttrium, terbium, ytterbium, erbium, like that. Holmia, somewhere it will be Holmia is the capital of Sweden, and nowadays it is known as the Stockholm. That holmium is one element where it is holmium. Okay, here the holmium is. Okay, now Holmia is the capital of Sweden. Nowadays it is known as the Stockholm. And one more is there, capital of Denmark, that is Hofnium, HF. Here the Hofnium is capital of Denmark, Hofnium. Nowadays it is known as the Copenhagen. Okay, so it's a very interesting that names of few elements are given based on the names of scientists. Glenn T. Seaborg, who discovered many of the actinides. So in the honor of Seaborg, the name is given as a Seaborgium. Niels Bohr, who put forth the concept of the orbital, name is given as a Bohrium. Then the scientist is which one? Röntgen, who discovered the X-rays. So William Röntgen, in the honor of scientist, the name is given as a Röntgenium. Then Einsteinium, in the honor of scientist Albert Einstein, Einsteinium is given. Enrico Fermi, scientist, who stated that proton-electron hypothesis is wrong one. According to the proton-electron hypothesis, about 2 centuries back, it was believed that electrons can be accommodated in the nucleus. But scientist Fermi proved that electrons are big in size, they can't be accommodated in the small-sized nucleus. So in the honor of scientist Fermi, the name to the element is given as a fermium, Alfred Nobelium, and many more are there. Okay. Names of few elements are derived from the names of planets. Here you will find the uranium based on Uranus, plutonium, Pluto, Neptunium, okay now, Ceres, Cerium. Like that, names of few elements are derived from the names of planets, names of scientists, names of places. Okay, so first group begins with the hydrogen atomic number 1, ends with helium atomic number 2. Second group begins with the lithium atomic number 3, ends with the neon atomic number 10. Third group begins with the sodium atomic number 11, ends with the argon atomic number 18. Then fourth group start with potassium atomic number 19, and fourth group ends with the krypton atomic number 36. Rubidium 37 to xenon 54. These elements are the member of fifth period. Sorry, all these are the periods. First period, second period, third, fourth and fifth. Sixth period begins with the here cesium, ends with the radon 86 atomic number. Seventh period begins with the these one. What we call seventh period begins with the francium atomic number 87. It ends with the oganesson atomic number 118. And students see this cerium to lutetium. These are the members of sixth period. Okay, na? Lanthanides are the members of third group and sixth period. Actinides, thorium to lawrencium actinides are the members of third group and seventh period. Okay, so this is about the some general features of the what we call general features of the modern periodic table. Okay, in next videos we'll see about the trend in periodic properties. For example, atomic radius, ionization potential, electronegativity, electron affinity, metallic, non-metallic characteristic, valency. What happens? Either increases from top to bottom or decreases, or increases, decreases, and many things we'll learn. Okay, so students, bye and thank you for watching.